Alright, today we're going to learn about constant acceleration, and I did a problem which is at t equals 0, a particle leaves the origin with a velocity of 9 meters per second in the y direction and moves in the x-planes with the constant acceleration of 2.0 I minus 4.0 j meters per second squared. At the instance, the x-coordinate of the particle is 15 meters. What is the speed of the particle? So we first labeled all the variables, and then we started with the x-axis. So we knew it's v squared is equal to v naught squared plus 2a delta x. So we plug in our variables. Since in v naught x there is no velocity because it only started on the y direction, so it's 0, and plus the 2 in our acceleration, which is our constant acceleration, we only got the x-axis, which is x, and this is y. We only got the x-axis and multiplied it by 15. So we got v squared x is equal to 60. And then since it has to be v by itself, we just square root it, and we got 7.7 meters per second. So that's for vx. And then we went to the y-axis. Since we needed to find time in this one, so we could use the formula of v is equal to v naught plus at. We got x is equal to v naught x plus v naught x times t plus 1/2 at squared. So we just plugged in our variables once again. So it's v naught, so it's 15 meters is equal to 0 because it's on the x-axis again, plus 1/2 at squared. So which means 15 is equal to 1/2 times 2, once again, because it's on the x, just a reminder it's on the x, t squared. So t squared would equal to 215 over 2, but the 2's cancel. So and since it's squared, you have to do t is equal to square root of 15 seconds. And then we would just plug in all of our variables back in, but with the y component. So v is equal to v naught plus at. So vy is equal to 9 meters per second, because it started with 9 meters per second on the y direction at t equals 0, plus -4 on the constant acceleration because it's on this one. It's -4j times the time, which is square root of 15. So by putting all that, we got to -9.5 meters per second. So after we got vx and vy, what we need to do now, we need to get the magnitude of it so we can find the magnitude of velocity. So what we did is v is equal to square root of vx squared plus vy squared. So it was equal to 7.7 squared minus -6.5 squared, which gave us v is equal to 10.1 meters per second. So by doing the x and y direction, by doing the x and y axis, we were able to get all this magnitude and find the velocity for both components.
Yeah.